Good evening to all. So today we'll solve the questions regarding a quantum chemistry 1D box and 2D 3D box concept. So the first question is, a particle is constrained in 1D box of a length 2a with potential energy V has given infinite outside the box and 0 inside the box, and they are asking about the difference between the levels of N3 and N2. So here are the options they have given. First, as we all of you know, that particle in 1D box, the energy value can be written as what? En can be written as what? N square h square upon 8 ml square. So this is the particle in 1D box energy, where N can be written as 1, 2, 3, etc. But they are asking the question energy difference between N3 and N2. So the difference del E can be written as what? The del E can be written as h square upon 8 ma square. So N3 minus N2, so I can write it as a 3 square upon minus 2 square. So the total difference is coming as 9 minus 4. Directly we can write it as a 5h square upon 8 ma square. So but here the box length they have given in the question, that is box length they have considered it as a 2a. So that's why here you can substitute the value as a, instead of a you can substitute 2a. So you will get 5h square upon 8 m 2a square, right? So here you will get substitute what? 8 m 2a square. So it is coming approximately 4a square. If you multiply the overall, the del E value, we will get it as, the del E value we are getting it as, that is a 5h square upon 8 multiply with here 4. So that's why I am writing directly, that is a 32 ma square. So this is the correct option. So the option D will be the right answer. Here the same question they are asking in different way. Here you see the question, the difference in energy levels of N2 minus N1 of a particle in 1D box has given in 6 units and of energy of the same units. What is the difference between the energy levels of N3 and N2 for the above system? So we know that the difference between 2 minus 1, that is at N2 and N1. So that means we are substituting E2 minus E1. So N value as 2, if you substitute 2 square minus 1 square. In the n square h square, we are substituting n value as n2 minus n1. So we will get 3h square upon 8 ma square. So this difference between second and first energy level, this difference they found as 6 units. So we are writing as 3h square upon 8 ma square. We are writing it as 6 units. But what they are asking? They are asking same, the question earlier we have discussed, that what is the difference between energy levels between n3 and n2. So we have discussed here, this is N3 and N2 difference is how much? 5h square upon 8 ma square. So now as of we know that h square upon 8 ma square value, we got it as 2 units, right? So if you substitute these 2 units in the 5h square upon 8 ma square, so 5 multiply with 2, so it will come as 10 units. So option D will be the right answer. So this question regarding a particle in 3D box, the question is the degeneracy of a quantum particle in a cubic box having energy 4 times that of a lowest energy is. Okay, so they are asking about the energy 4 times which is the lowest energy. So the lowest energy is called, that is a E1. So generally for a particle in 3-dimensional box, the lowest energy will become equals to what? That is nx square, ny square plus nz square and h square upon 8 ml square, right? The lowest energy nx, ny, nz value should become equals to 1. So if you substitute, you will get it as a 1 square plus 1 square plus 1 square, h square upon 8 ml square. So the overall value for the lowest energy E1 value, we get it as a 3h square upon 8 ml square, right? But here they are asking about the cubic box energy, the degeneracy energy having 4 times to that of lowest energy. That means E2 can be become equals to the 4 multiply with 3h square upon 8 ml square. That means it is becoming equals to the 12h square upon 8 ml square. That indicates what here? The nx square plus ny square plus nz square must be equals to 12. This is only possible when we substitute nx and ny nz value as 2 to 2, right? This indicate what? It is a singly degenerate. So the degeneracy of the value is given as 1. So here option C will be the right answer. So the another question is the electron of mass m confined to a 1D box of length b. Box length they have given it as b. And if it makes a radioactive transition from second excited state to ground state, what is the frequency of a photon emitted? So as we know, for a particle in 1D box, the energy value is n square h square upon 8 ml square, right? As we know, the length of box here they have given how much? B. So we need to substitute, instead of L, we are going to substitute B. So n square h square upon 8 m b square. The energy always equals to h nu. So h nu value can be written as this one. As we know, the ground state as E1. So E1 indicate what? The ground state energy is 1 square. So I am writing directly as, not writing 1 square, h square upon 8 mb square. Whereas second excited state means E3. So you will write it as 3 square. That is a 9h square upon, here 3 if you substitute, 9h square upon 8 mb square. So what is the difference between E3 minus E1? The difference between E3 minus E1 will become as 8h square upon 8 mb square, right? Isn't so? Now if you cancel these two, so you will get it as a h square upon 8 mb square, h square upon mb square, and as we know, this is coming it as a h nu. But they are asking about the frequency of the photon. So that means mu become equals to what? Mu become equals to h upon mb square, right? So the option here C will be the right answer. So thanks for watching this video.